March Madness, this is good timing. March Madness is an example of exponential decay. And this, I want you to circle this. This is the equation that models March Madness.
Whoa.
It says y is the number of teams left after X rounds of the tournament. The tournament begins with 64 teams. So notice the equation. You see the 64 in front?
Yes.
That's the initial amount. We learned that when we did M&Ms, remember?
Yes.
And we did the little scatter plot, and that A value in your calculator was like about how many M&Ms you started out with. So same thing here. What do you think 0.5 is referring to?
Half or limiting?
Half, exactly right. So after if you're in a tournament and you play one round, how many teams are left? Half, right? Because two teams play each other, one has to lose. So after one round of the tournament, there's half as many left. So you can see here, why is this a 0?
Because it's
It's not been played yet.
Yeah, no games have been played yet. So how many teams get into the tournament?
64.
Yeah, no, actually there's 68 now. You guys know about that? They call it the first 4, but technically they're not considered to be in the tournament. So the first 4 play a round, and then if they win that round, then they're included in the 64. So after one round has played, how many teams are left? 32. After two rounds are played, we have, what's that called?
Sweet 16.
The Sweet 16. And then we have the Elite 8, Final 4,
Finals.
the Championship game, and then
The
winner.
the champion, which
Too bad
is
Mizzou's out of it.
Missouri was always
Victory.
not Mizzou this year. Sad face.
Or next year
Kansas
when
is
you guys
still
do
in.
that.
No, probably next year.
Definitely next year.
Okay, so we're gonna apply that
That's like a-
to these equations here. So does this look familiar-ish?
Yes.
Sorta.
This has the X.
Yeah. What is a K value done all year long?
Vertical shift.
Up and down. Good. What does H do?
Horizontal shift.
Good. Left and right is horizontal. And then the A value is going to.
Y-intercept. Compress. Initial.
It's kind of weird with exponentials. It does kind of stretch and compress. Now this is. I want you to actually cross this out.
Oh. No.
It's actually only. It's only the y-intercept if there's no h value, like if h is 0, and I'll show you why in a second. But for now, let's go ahead and fill out our a, b, h, and k. So look at the formula. Lawson, what is a?
2.
Nope.
No. I'm wrong.
Colin?
It's 1.
It is 1. Why is a 1?
Because you don't need one half.
Yeah.
Zero.
Oh.
B. I get it now.
These two.
B, they use B because it's the base of the exponent. So every exponent has to be a base. So if there's only one number there, that is B. So B is 2, which means I could rewrite this as 1 times 2 to the x, right? B is always the base of the exponent. So if there's nothing there, Haley, then A is 1. Okay, what is H?
False.
1.
Is there anything added or subtracted from x?
No.
No, so it's 0. And is there any k value out back of this graph?
No.
No, so k is 0. So if it hasn't moved up or down and it hasn't moved left or right, it's usually centered around the origin at 0, 0. Okay, so let's see what happens here. I want you to plug in -2, -1, 0, 1, and 2. Now, you guys look up here. 2 to the -2nd power. You should be able to do this without a calculator. What does a negative exponent do to a number?
What, does
Yeah.
that double with fractions?
It puts it under 1. So 2 to the -2nd is 1 over 2 to the +2nd. You remember that? And what is 2 squared? So how many of you got 0.25, aka 1/4?
Yeah.
Yeah, so if you remember that, you didn't need a calculator, but that's okay. So this is 1/4. What is 2 to the negative first power? In other words, 1 over 2 to the first. 0.5 or 1/2. Anything to the 0th power, do you remember that?
Yeah.
Is 1. If you plug in 1, what is 2 to the first power? And what is 2 to the second power? 4. So go ahead and plot these points. So left 2, up a 4. So that's really close. It's kind of small. Left 1, up a half. Over 0, up 1. So our y-intercept is 1. Over 1, up 2. Over 2, up 4. Now what do you think is going to happen if we continue this?
Exponentially getting.
Let's say if I plugged in 3, what's probably going to come next?
It'd be
8. Plugged in 4, it's going to be
16.
16. What's happening each time to the outputs?
Becoming bigger.
1, 2, 4, 8, 16, 32, 64. What? It's doubling, right? This value, the B value, is the rate of growth or decay. So is this a growth or is it a decay? Growth. It's doubling, 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 doubling. So you can see this graph that is skyrocketing. Boom, straight up in the air. Because if you double something and double something and double something, it gets really big, really fast, right? Now I'm going to kind of cue you in on something new. What do you think is going to happen if we go further to the left?
Well, it's the same thing, but it's decay.
It's just cutting in half.
It's cutting it in half. So let me ask you this. See that door right there?
Yes.
Okay, my goal is to run into that door. But I can only do it by getting half as close each time. So if I get half as close to the door, I'm now going to be about here, right? And if I get half as close to the door, I'm going to be about right here. And then I get half as close, and I get half as close, and I get half as close, and I get half as close. And then, am I ever going to get to the door?
No.
You
gotta try harder.
How much is always left?
Half.
Half, right? So theoretically, will I ever hit the door?
No. You can try harder.
Thank goodness.
So you'll never hit 0.
So now think of that door as the x-axis. Is this red curve, if it's getting half as close to the black line, half as close to the black line, half as close, is it ever going to hit the black line?
No.
Ooh.
That's spicy.
This is a new concept that we're going to learn about today. I'm not going to tell you what it is yet, but keep that in your head. Okay? Go on to do number 2 on your own. Here. First of all, Kelsey, what is A? 2, good. Kobe, what is B? 1/4, good. Isabella, what is H? 0. And Stephen Moore, what is K? Good. So in other words, it didn't move left or right.
Nice.
I didn't do the domain. I'll go back to it.
We don't need to move this.
We'll do it on this one. So, what was my first Y output L? You plugged in -2 and you got
32.
Good. Thank you, L. Avery, you plugged in -1 and you got E-Man. You plugged in -1 and got 8. Thank you. Cameron, you plugged in 0 and got
You say Cameron or
Cameron. No.
2. Oh, shoot. My bad. 2.
1/4 to the 0 power is 1, but there's a 2 in front, right? 2 times 1.
Yeah.
So this time, what do you think this is doing? How much is left each time?
It's 4.
A 4th, right? What's a 4th of 32?
4.
8. What is a 4th of 8? 2. Stephen Mernick, you plugged in 1 and got 1/2. Good. And Jace, you plugged in 1/2 and got 1/8. Okay, go ahead and plot these on your graph. So is this one a growth or is it a decay? Decay. Yeah, it's a decay this time. But it's the same concept, you guys. Now we're going to the right as we get smaller. So if I get a fourth is close to the door and a fourth is close and a fourth, how much is always going to be left?
3/4.
3/4, or vice versa. If I'm getting 3/4 is close to the door, there's 1/4 left. So am I ever going to get to the door?
No.
No, there's always something left, which is kind of hard to think about. It doesn't make a ton of sense. But once again, this graph is going to come down, and it's just going to ride along the top of the x-axis. A fourth is left, a fourth is left, a fourth is left, a fourth is left. I'm getting good at that. So now, I'm going to show you how we draw this new thing. It's kind of like a force field, right? What's going to happen if you run into a force field? You're going to bounce off, right? So can you ever be where the force field is at?
No.
No. So the way we graph this is with a dotted line.
That was a nice dotted line.
Now that dotted line has a special name, and some of you guys, I think, right ahead has a weird name.
It has a bad word in it. That's what
Yeah, you can't say it.
Oh.
It's called an asymptote.
Oh, coach. No,
Can't
they're
say
bad.
that.
An
I request
asymptote.
the class change.
An asymptote.
it is. Wow.
That is the force field that your graph is never going to cross. So now that we've kind of talked about that, let's practice our domain and our range. So what's the furthest left this is ever going to grow?
Infinity.
Infinity.
Yeah, it's very steep, but eventually it'll keep going to the left, right? It's not a vertical line. So negative infinity, and then is it ever going to stop skimming along the top of the water? No, it's going to keep going to the right. So negative infinity to infinity, or all real numbers. Okay, now the range is the weird one here.
Oh, I got you.
Is that graph ever going to hit my arm down here?
No.
No. At what point does the graph start?
1/4.
I'm so confused.
No, it has to be great. It has to be greater than 0.
Good. It's going to get really close to 0, right? But never quite there. Hold on. Sure. Go judgment.
Yo.
So, the way that we do this is 0. But is it ever going to hit 0?
No.
No, so we use a parenthesis. And then, technically, I know to the right it's going down, but this half of the graph does go up and up and up forever, right? So when is this graph ever going to stop going up?
All never.
Never. So 0 to infinity. It's not all real numbers because there's nothing down here. There will never be anything down here. So above 0 is what we're saying. Not equal to 0, but above it. You know?
Would that parentheses by the 0 be a bracket instead of a
No, it's a parenthesis because we're never going to hit 0.
okay.
Right? Because there's a force field on 0. We can't ever hit it, so we put a parenthesis to realize we're not going to equal it. Okay, what is the y-intercept? Write it as a point over 0 up 2. So write it as the point 0, comma 2. What about the x-intercept?
Never crosses.
No soul.
No soul.
Just none. You can just
Should we
write that.
put in a...
I don't know.
There is no x-intercept. Don't put 0 though, right? What are you saying if you write the number 0?
It's 0.
It's 0.
Then it crosses the x-axis at 0. It doesn't. It's just none. So here it says graph the I want you to actually do this time. So we're not going to plug in numbers manually. I want you to graph the equation in your calculator. So go to y equals. And I want you to type in 2 to the x plus 4. And then you're going to have to arrow out of the exponent because this minus 3 is down on ground level. It's not up in the exponent. Real quick before we do that, Jarrett, what is A?
Oh, that's... It's 1.
Good, it's 1. Why is it 1? Because 2 is the base. So B is 2, which means there's a 1 in front. What is H, Cameron?
Oh, -3. No, 3. 4.
Wouldn't it be negative?
It's -4. It's the opposite of what you see.
Yeah.
And Cammy, what is K? -3. So you guys should have a good idea of what's going to happen based on H and K. But go ahead and put it in your graphing calculator and graph it. I want you to go to, so here's our graph. I want you to hit second table. And I want you to now, you might have to scroll up and down, but I want you to fill in the table based on the x values that I gave you. So go to -6, and then -5, -4, -3, and plug in what you have. So here are our definitions. Go ahead and fill in your blanks.